if we could effectively capture the sun's energy and store it at will, then we can address pretty much all of the different kinds of energy needs that we have right now. We would be able to apply some of this toward the fueling of the cars that we use in our daily lives. We can apply it to the individual home electricity, but we can also think about ways in which solar can be applied much more broadly to our portable devices, much more broadly to utility power overall, and we can distribute it across the world in ways that it's very difficult to distribute any other form of energy. Rather than having to use transportation systems to get fuel or power energy to different places, we can think of an entirely different way of arranging a utility grid, for example. Now we have something that is accessible to all nations, regardless of where they are, and we think of unique ways of getting that energy to everyone. It also means that there will be a different way of thinking about energy, that we won't have to think about energy as directly being associated with wealth. And I think that is something that will have a huge impact in the world. I'm very optimistic that we can get to the solutions of these problems. Some of them are very difficult ones, but right now we have a huge emphasis on how we can address solar energy. And we're already seeing some of the beginnings of change in the development of solar systems. I think one of the issues right now is maintaining a high efficiency while decreasing the cost of the materials associated with solar. And a lot of the projects that we've talked about today in my own lab and in the labs of many of my colleagues actually look at more abundant materials, materials that can be more readily processed, and materials which can cover a large range of surfaces, from the surfaces of roofs to clothing and fabric. I think with this level of innovation, we're going to get at how we can achieve solar energy on a much broader scale than we have now. I think we're going to see those changes and that they're going to be implemented. MIT is a wonderful place for solar energy research because it has such a large range of disciplines that are engaged in this area. In fact, the MIT Energy Initiative enables not only scientists and engineers to interact with each other, but there are people in economics, there are people in technology and policy, there are people even in the humanities, arts, and social sciences engaged in this problem. There are so many different perspectives that have to be addressed with regard to not only the science, which involves chemistry and math, physics, engineering on all levels, but also the way in which solar can impact economies, the way that solar can impact culture in various ways, and the distribution of wealth in our world. So it's very important to have all of these components available in one place, and MIT provides that place to cross disciplines. My MIT education was not only a wonderful experience, but it prepared me to address problems that are very complex. I'm a chemical engineer. I got my bachelor's degree at MIT, and then I went away and worked for a little while. During that time, I had an opportunity to absorb different kinds of problems. Then I came back to MIT to get my doctoral degree, and I found that this place gives you the ability to not only apply your resources to one research problem, as one would in a PhD thesis, but to get to know people working on other problems across fields, and to have those conversations, which are sometimes in hallways or in seminars, that allow you to think about different ways of applying your science. So I ended up working in areas and fields that I may not have anticipated years ago, and I think all of that is due to the fact that MIT prepares students to not only solve complex problems, but to talk across disciplines. One of the unique things about MIT is that there is a level of excellence everywhere at MIT that can't be rivaled anywhere else. I have been able to experience some wonderful academic environments, both in my travels and in my experiences before returning to MIT. And yet MIT is the only place where I know that I can go next door and talk to a biologist who's one of the top biologists in the field about, let's say, biofuels and how we can apply biological organisms toward an energy problem. It's one of the few places where I can go next door and talk to a top of the field physicist. So I can be proud to be an engineer at MIT and interact with my fellow engineers, electrical engineers and mechanical engineers, know that they are at the top of their field and have tools available to them. But I can also go anywhere in the Institute and find this, and I think that's very unique. I actually think that the students are the most exciting part of waking up and arriving at MIT every day, because I have this very exciting and motivated group of people working on problems that are just exciting and world-changing or life-changing. The students that I encounter on a daily basis are energetic, they're excited, they want to apply their skills, and they often come to me with new ideas, things that I hadn't thought of before. So one of the things I love about working here is that this never changes. The students have always been this way. I can go down the infinite corridor and know that there are students to my left and to my right who are, working on these very important problems, are thinking on very intensely about how their work impacts others. And I think that's something that is a true gift, something that MIT has always had and has always benefited from.